This conference will now be recorded.
Hi, good morning all.
Good morning, sir.
Good morning, good morning.
Good morning, sir.
Good morning, very good morning. Is I audible, Deepali? Harshal? Others? Aruna? Is I audible or not?
Sound sound good. There is no issues from my side. It's all good.
Okay, fine. Last class we discussed about what is Snowflake, what is Snowflake, and why Snowflake. Why Snowflake? So what is Snowflake means? Snowflake is a cloud computing, cloud cloud data warehouse. Snowflake is a cloud data warehouse. So it is a combination of any cloud vendors like present cloud vendors like Azure, GCP, and where we can call it as a Azure, AWS. Also, you can choose as a any of our cloud providers for storage and computing. So with the help of storage, with the help of present cloud vendors, so this Snowflake will do the operations in the form of computing and storages. So that Snowflake is a cloud data warehouse, it's maintain his data into the cloud systems. Okay, with a url you'll get access to the Snowflake. No installation, no software installation and everything. We just get a some url instance, and with that instance you just use your uh, Snowflake. Okay, and then why Snowflake means that we have a lot of options. We already discussed about the why Snowflake. So if you come to the why Snowflake, first, hybrid architecture, it consists of shared disk and shared nothing architectures. So storage and computing are separate. And also we have a hybrid columnar storage. That means it's a combination of row and columnar partitions. And whatever the micro partitions in the form of hybrid columnar storage will be automatically no need to use involved by users. Okay, auto optimizers also there. Okay, time travel period, let's say for example if any thing will be happened on your tables, like for example you wrongly updated before 20 days back or 90 days back, up to 90 days 90 days you can travel on the time and you can make changes for your activities. Okay, so that means that the retention period of that particular objects will be up to 90 days based on the type of object. Okay, and also where we have a extra 7 days you will get after 90 days, also you will get extra 7 days, but there is no user interference there. You need to contact to Snowflake. Snowflake will provide your data in the form of database failure or any disaster recovery managements like that. Okay, and the data sharing also possible. If the Snowflake account people, for example you have a Snowflake account, so you can directly share with your Snowflake account people. Otherwise some people don't have any Snowflake accounts, we can create one Radar account for them, and we will share that credentials to that guy, and with that Radar account he can access that data whatever the sharing from the provider account. Simply we can use data sharing, and live data is available, and then the persons who are utilizing our data by share will be only getting read only option. That means secure also it will be available. Okay, and zero copy cloning. Actual copy means, like for example, if you copy the data means it will consider extra storage. Now in Snowflake it won't consider like that. It will be considered only one storage. Let's say for example you copied 1000 GB of data into another copy. How much GB? Then it is 2000 GB. But in Snowflake it will consider only 1000 GB. Why? Because the storage will be pointing to the actual present micro partitions only. It won't create any storage. Okay, whatever the storage, it will point into the extra cloning table. Okay, so for that it is easy to manage your data, okay, with a less storage cost. Okay, next task and streams. So whereas the streams will be change cdc means change in capture, change in data capturing. It will only captures the data which was changed in data, which was changed data. It will only captures the data which was changed in data. Now coming to the task. So if you want to schedule your things, so we can use a task for the scheduling process. These all actually the benefits. Mostly we have a tram travel, auto optimizers, micro partitions, call it as hybrid columnar storage, and hybrid architecture like shared disk and shared nothing architecture. If you want more detail, just go to the previous class. Okay, so I just briefing everything in detail. So please go through that. After that you have any doubt also, you can ask me in next class. So that's all. I think just go with some next 5 to 10 minutes for the workflow, how it will be exactly available in real times. Okay. So actually this is the actual overall flow. Okay, let's say for example if you talk about any applications, like companies will use different applications to maintain different operations. Okay, in this case company is doing their operations by maintaining the data into a different OLTP systems called databases. Okay, what is OLTP systems? OLTP means online transaction process. Okay, so it will be maintain your data, whatever the online transactions maintained by the particular application will be maintained on the databases. So to maintain these OLTP systems, consider into it majorly two types. One is RDBMS database. In generally I'm talking, sir, I'm not in specifically I'm not talking, in generally I'm talking. Let's say we have a two types majorly. One is RDBMS database and other one is NoSQL database. RDBMS means relational database management systems, whereas NoSQL means not only SQL. So RDBMS databases are most popular databases, most popular and usage also, usage point of also more usage, okay, compared to NoSQL. Okay, NoSQL, like not only SQL, call it as a MongoDB. Example is MongoDB. That also will be maintained as a database. It will maintain the some whatever the online process happened with the different applications will be maintained as a transactions. Okay, that will be also call it as a OLTP systems. Please mute yourself. Please mute yourself. Harshal, please mute yourself if you don't mind. So all these transactions will be maintained on the OLTP systems called databases like Oracle, DB2, MySQL, whatever the NoSQL databases like MongoDB, like that. So all will be maintained some as a transactions or ACID properties, which was generated by a so and so application. Let's say, for example, what is ACID properties? Example,
consistency, isolation,
whatever,
Atomicity,
everything. Simple
isolation,
understanding.
durability.
Yes, absolutely. In simple understanding, for example, if you do any transactions with a bank, okay, for example, so for example, you want to transfer some money to the some other ex guy, okay, so you just open your account and you just make your account selection, and after that you need to send the money. Okay, after sending the money, it won't send directly immediately to that person. First year the money was detected from your account, and after that if money was validated and credentials was validated, then the money will be sent to so and so account. Okay, after some time. Okay, or after seconds, milliseconds, it will credit it to their user accounts or X person account. Okay, for example, if these process will be failed anyway, what will happen? Immediately that will be happened rollback. The transaction will be rolled back. This all we consider as a asset properties. This all we consider as a asset. That all asset properties will be maintained on the databases for the future reference. Okay, so in this case, these Oracle DB, MySQL or RDBMS databases, okay, where we have a NoSQL is a MongoDB is the example of NoSQL databases. So it is a one type of database. Okay, what is the main difference between RDBMS database and NoSQL database?
Structured and unstructured data.
Both, whatever it may
Semi-structured.
be. The unstructured data.
RDBMS databases are weaker in capacity, but the performance will be high. But whereas coming to the NoSQL databases, the capacity is more, but the performance is less.
Not like that. Simply we can say it as a yes. There is a differentiation between the two servers, so which will maintain only one structured data. Here we can maintain even a database will maintain semi-structured data also. But NoSQL databases they have chance of storing unstructured data also. But the main purpose, main difference is not that one. So where we have a RDBMS databases, they are weaker in capacity. Weaker in capacity. Performance wise, they are good. They are good. Coming to the NoSQL databases, the stronger in capacity. They can maintain huge data while compared to RDBMS database. Not like bulk data. While compared to RDBMS databases, they are good in capacity. Okay. And performance wise, okay. Performance wise, okay. But they are weaker in batch processing. Let's where we have a RDBMS database, they are good in online process and batch processing. There we have a two types of processes are there. One is online and other one is batch processing. Online means user interactive transactions,
Contact.
user interaction, whereas batch means user non-interactive. Let's say for example, online means a user is trying to send the data to some other X person. A user is checking for the balance. A user is checking for the latest transactions. Okay, so these all will be online transactions. Where we have a batch means end of the month, a manager will add some interest rates to your accounts, saving accounts, and also he will add some money to your accounts who has having a FDs, fixed deposits. Okay, he will calculate all the statistics at the end of the month, how many users are doing lots of transactions, what is the last month transaction. Somewhat batch processing operations will be there. So old data. So you need to work on some old operations. Okay. So where we have a manager doing the activities, we'll call it as a batch processing. Whereas a person, a user is doing the activities, call it as a online processing. Got my point, sir? So that here, whatever the batch processing, that in that batch processing, NoSQL databases are weaker. Where we have a RDBMS databases are stronger in both online and batch processing. So then RDBMS databases are stronger in both, then why NoSQL databases will come into the picture? So because of stronger capacity. Because of stronger capacity. But still people are using RDBMS databases only. Yes, NoSQL databases also using, but most popular and most used databases are RDBMS databases. You got my point? Now, the RDBMS databases or NoSQL databases, whatever the databases we are calling as OLTP systems, online transactional process systems. Okay. Now, sir, there we have a databases. Now, why these data warehouses are needed? Why these data warehouses are needed?
To perform the analysis.
To perform the analytical operations and also for the feature purpose, feature operations. Let's say why, sir? So where we have a RDBMS databases like a databases, you can directly perform the analytical operations on the databases. What will happen, sir? There we have a chance of performance issues. Let's say for example, RDBMS databases is maintaining last 2 years data. So you can't maintain 30 years data in RDBMS databases, no? Okay. Let's say for example, you want last 2 years analysis only. Some Power BI and Tableau guys and data scientists are attacking on RDBMS databases. What will happen to the RDBMS databases? Sometimes RDBMS databases are writing some data, and you are reading one side, what will happen to the RDBMS database? Definitely it will be chance of hanging, so that your real-time operations will be shut down.
Yes.
To maintain real-time operations will be too critical, and you are doing same at a time, means what will happen? Your real-time operations will be shut down, crashed or something, whatever. You can't maintain it. So further, we will use a data warehouses. In the 2000, earliest 2000, at the 2000s, no databases, data warehouses are there. Databases are in 1975, starting from 1975. Actually, database came from the paper. Okay, our Asian people will use to store the data on sand. Sand means land, and after the stones, after the trees, after that paper, we just call it as in Telugu talapatra. Talapatra.
Yes.
That is also considered as one data storage.
Hmm.
Okay, and after that they will use to store the data in text files, and after that they used to store the data in Excel files. Excel is the starting of database. Actually, Excel is also a database, starting in basic database. Okay, and after that they create some 5 to 6 norms. I don't know what are the 5 6 norms. If you clear the 5 to 6 norms, or if you satisfy that 5 to 6 norms, then that will be called it as a database. So where we have a RDBMS, Oracle database, MySQL, Portugal, all will satisfy the 5 to 6 norms. That's why we call it as a database. So in earliest 2000, no databases exactly there. All will maintain on the databases only. If any old data will be there, they will maintain as a storage. Storage means first they will start with magnetic tapes. Do you know magnetic tapes? Anybody heard about the magnetic tapes?
It's a tape recorders in use.
Magnetic tapes. So there we have a cassette. Okay. So the reel will be there. The data will be maintained on this place. On two areas of this is started 1928. Before database itself, it will be there. 1975 database was introduced, but in 1928 the magnetic tapes will be there. In these tapes they used to store the data. Earlier days, 90s.
Yes.
And after that, what will happen? All this data, for example, you are holding some 4 years data in database, 1 year data, and last 3 years are maintaining on these tapes, means to do some maintenance for this tape, there is a lot of critical task will be there. Why? Because if you want to do this maintenance, okay, if you want to do some maintenance for the tape, you want to transfer entire data to new tape, and you need to do maintenance for that tape.
Yes.
Maintenance cost is too
High.
high and also critical.
Hmm.
So much problems are facing on the time of maintenance of tape. Okay, after that they got some
Yeah.
floppy floppy disk, and also we have CDs, DVDs.
Hmm.
For that also there is a lot of chance to corrupt your data. Like for example, in CDs, if you have some small scratch also, what will happen? Your data will be some corrupted. Okay, let's say for example, in olden days we used to store your movies in your CDs. Okay, so while playing your movie, sometimes you will get some interruption. Why? Because you have a scratches on that CD. Your data will be corrupted. Okay, so after that what will happen? They again problem is facing at 2000s, around 2014, 2004, 2005, like that, 2003, 2004, like that. So the data warehouses was introduced, that is called Teradata, Netija, Vatica. Whatever the, at the time, Teradata, Netija, and Vatica are the data warehouses. Data warehouses. What is the purpose? It is used to maintain the huge and bulk of data. But whereas Vatica will support only less than 200 TB. At the time, industry standards stated that only Vatica will support for less than 200 TB. So that if you talk about it, Teradata will rule so many days. Okay, so it will maintain around the 300 TB storage, up to 300 TB. It will support for up to 200 to 300, more than 200 TB. Okay, 200 TB. Sir, Teradata is maintaining so that in this scenario, please mute yourself. In this scenario, Teradata act as a data warehouse and it is maintaining huge and bulk of data up to 2. It will support for 200 to 300 TB of storages. Okay, whereas Netija, Vertica are not that much of standards, so that Teradata is most popular at that time in 2003, 2004. But still, data is growing more. Let's say if you talk about some companies, they are holding around 30 to 40 years of experience. Yes or no? Let's say SBI Bank, okay, or HDFC Bank. They are holding lots of years bank data. So in this case, it is more than TBs. Yes or no?
Yes.
GBs, TBs, a petabyte also it will change.
Yes.
It will go through petabyte. Then Teradata won't support.
Yes.
So at the time in the 2006, 2005, the systems we call it as a Hadoop systems will came. Hadoop,
Systems.
Hadoop systems will come to the picture. Hadoop is the big data highway in the form of highway. You got a data warehouse. So in these Hadoop systems, okay, you can maintain huge and bulk of data. It's more than 300 TB. It supports for unlimited data. It supports for unlimited storage. How it will be stored? Unlimited data. So where we have a database is a strong, weaker in capacity. Why? Because 256 nodes are support. It will support for 256 nodes. What is 256 nodes means? To servers. Got my point?
Yes.
So it will have a limitation like 256 nodes. Whereas Teradata only supports for 1024 nodes.
Two for
1024 nodes per cluster.
Mm.
Okay. But whereas Hadoop, there is no limitation. You can include thousands of servers into one cluster. Like that, multiple clusters you can create.
Okay.
So let's say, for example, one server is storing 100 TB of storage. You are maintaining 100 servers means 100 into 100, 10,000 TB of storage you can maintain. Like that, there is no limitation to have a cluster like n number of servers added into the cluster, and this cluster act as a one storage. So that Hadoop systems will maintain huge and bulk of data. Sir, Hadoop systems are maintaining huge and bulk of data. So even it will support for unlimited data, na? So why Hadoop will be not using right now? Why?
because it is on premises.
Yes, because it is on premises. Because it is on premises. On premises means you need to maintain everything in your company, and you need to take care about the investments. You need to take care about the limitation. You need to take care about the wastage, and you need to take care about the latency issues. Heavy hardware requirements are there, and also maintenance overhead, no disaster recovery, and time to take installation also. Limitation is there. Waste of resources are more, and we need a admin, we need a infrastructure, we need a electricity. Everything you need to take care. That is all ethic process, and cost performance, most cost performance. So that's why people are looking for the cloud. Cloud is nothing but all this will be provided by some other guys. We will just utilize our resources and pay the money as per your usage. So for that, Hadoops are not interested because of that are in on premises. Then people at the 2006, we have a cloud computing. Cloud computing was introduced on 2006, but started used at 2016. After 10 years, I think. Even Hadoop also after 10 years only it will be used. Around 2011 like that it will be used in the market. Same like that cloud also 2015, 2014 like that it will be used. Okay, cloud was introduced. But coming to the data warehouse point of view, what are the data warehouses we have in the cloud? First one is Snowflake. In 2013 it was introduced. Okay, it was founded on 2013. So where we have a Redshift, BigQuery, Synopsys, Teradata, around 2013, 2012, like that only it was introduced, founded. Okay, these all are the cloud data warehouses. That means they actually data warehouse needs a two things. One is computing and storage. Computing and storage. This computing and storage will be created on your company premises only. That refers to on-prem. This computing and storage will be getting from some other cloud vendors or some other place via internet. You are accessing that resources. That refers to cloud. So where we have a Redshift, BigQuery, Synopsys, Teradata, Snowflake. Snowflake. For all these guys, the computing and storage will be provided by some other person. Please mute yourself, man. The computing and storages will be provided by some other guys, and you are utilizing that computing and storages via internet. Okay. But here, one thing you need to remember, Snowflake will be supported with a major three vendors. One is AWS, Azure, GCP. That means computing and storage will be provided by AWS, Azure, GCP. Whatever you want, you can choose. But where we have a Redshift, Redshift is a product of AWS. That means AWS will provide computing and storage. BigQuery, Google product. Google Cloud will provide computing and storage. Whereas the Synopsys, it is a Azure product. Microsoft. Azure Cloud will provide you computing and storage. Whereas Teradata having a own cloud. Sir, Teradata having a own cloud. Synopsys having a own cloud. BigQuery having a own cloud. Redshift having a own cloud. Whereas Snowflake is why Snowflake is utilizing present vendors like AWS, Azure, GCP. There is don't have any own cloud. Yes, it has a own cloud also. If you want, you can go with own cloud also. If you don't want to go with own cloud like Snowflake, you just go with a present major vendors like AWS, Azure, GCP at the time of installation. Got my point? Now, sir, all this database data into a data warehouses, then what is the purpose of data warehouses? Data warehouse will the purpose of analytical operation for feature purpose. It will maintain use and bulk of data. Use and bulk of data. It acts as a centralized system. It will source the data to the multiple things. Got my point, sir?
Yes.
What is the main difference between database and data warehouse? Database is a OLTP system. Okay, it will support for the limited period of data, and it will made for writing operations. It will made for writing operation, not for reading operations. Okay, and it is faster in writing operations. Okay, and it will have a limitation of 256 nodes. Okay, in the cluster. And coming to that, there is another important thing is it won't support for MPP architecture. What is MPP architecture? Massive
Massive
parallel
parallel processing.
processing. At a time, multiple processes are involved to process your data. Let's say, for example, one person is doing the activity for 10 minutes. If I involve 10 people, how much time it will take? 1 minute, now? One person taking 10 minutes.
Yes.
If I involve 10 persons, how much time it will take? 1 minute only,
1
na?
minute. 1 minute.
Got my point?
Yes.
Okay. So same like the multiple processor not involved, single process having single activity.
Yes.
So MPP, it won't support for MPP architecture. Whereas data warehouses are, call it as a OLAP systems, online analytical processing systems. Okay. And it will support for huge amount of data, unlimited data. Okay. And also it will have a MPP architecture, massive parallel processing. Sir, where data warehouse will support for current data, only historical data. Yes, sir. Modern data warehouse will support for current data also, historical data also. Clear, sir?
Yes.
Now, so why we are going with data warehouses? We already discussed. Like we have a auto optimizers, good storage capacities, and computing and storage are separate. Everything is full. Okay, after getting the data into data warehouses, and other people like Power BI, Tableau, like business analytical people and market people will choose that data and create their reports, alerts, dashboards on their own UI. Whereas data scientists will collect the data and create some predictive analysis and forecasting activities. Okay, and whereas a data scientist immediately applies some algorithms and find out some activities. Data engineers will shape up your data. Whereas data mining and data monitoring people also utilize the data and create their reports, alerts, dashboards from their own UI. Clear? Now, what is ETL in that? Now, I didn't talk about ETL till now.
Yes.
Why? Because you can directly get the data from databases to data warehouses, modern data warehouses. No ETL involved. But in the olden days, what will happen means whatever the data is data into data warehouses, that time they will have some struggle to send the data to a data warehouses. Before sending the data to data warehouses, the data needs to be clean. The data needs to be cleaned and changed for your requirements. So for that, you need to do some operations like ETL operations. ETL means extract, transform, load. The ETL tools like Informatica, Data Stage, Talent, MSBA, SSIS, Scoop, ADF. Okay, these all are, some are on-premises are there, some are cloud are there. Whatever it may be. On-premises means the servers are in your company premises. Okay, whereas cloud means the servers are in some other place via internet you are accessing. Whatever it may be. Okay, the purpose of these all tools are ETL, extracting the data from the data sources, transform the data. Okay, transforming means conversion, modification, cleanupping, filtering, okay, aggregating. All will done, and after that you can load the data into a data warehouses. After that, the data will be loaded into a data warehouses. Let's say, for example, you have a on-premises data warehouse ETLs. On-premises ETLs also will collect the data from the data sources and transform the data and load the data into a on-prem data warehouse called Hadoop systems. Got my point? Now Hadoop system will maintain huge and bulk of data. But whereas this ETL process is slowed down for bulk of process. Okay, first, okay, some certain limit, it will be okay for the industry standards. But you are getting huge and bulk of data means again these ETL systems also will be shut down now. Yes, that getting a performance issues now. So further to avoid that such operations, what they will use is in getting the data into Hadoop systems, they use a Spark. Spark is a compute engine. Computer means it will get some power to do some operations very faster. So that ETL, a combination of ETL, on-prem ETL to Spark with Hadoop. Spark is for online computing, sorry, on-prem computer engine. Okay, Spark will support for Hadoop. Why? Because Spark we call it as a compute engine. Okay, it is helpful to process huge amount of data into Hadoop systems. Okay, and it needs a cluster. Hadoop is a cluster now, whereas that cluster will be used to process our data. Spark. That's why Spark will support on only on-prem. Only on-prem. Very important interview question. Okay, sir. Let's say for example you are using a cloud ETLs. And your data is into cloud like Snowflake or Redshift or BigQuery or Synopsys or Teradata. That time, is Spark will supports? No. Databricks. Data? Databricks will support. We will use it to process ours. Why? Because Databricks is also compute engine like a Spark. Spark and Databricks are same, sir. Spark will be on on-prem. Databricks is on cloud. Some doing of activities is different, but purpose is same. Got my point? Databricks. Somewhere you listen Azure Databricks. Anybody in listen about it? That is for the Azure product. Same Databricks only, but Azure products. Got my point? Here, instead of these storages, they will use databases also, or some like data lake or S3 buckets or something like that. Okay, different operations you can use in this data warehouse. Instead of data warehouse, we can use storages also. But analytical process will be done with a data. For example, your data is in S3 storage. You can't do analytical operations on the S3. So we need to connect with data warehouses. From there, you need to fetch it. For that, you need to send the data to S3 to data warehouse, and you need to maintain data warehouse there itself, data in the data warehouse itself, and then you need to use for the feature purpose. This is what actually happens. Okay, So ETLs you got it, extracting, transforming, and loading. Databricks you got, data Spark you got. Now please mute yourselves. Now coming to the integration purpose, after the data warehouses, there we have a Power BI, Tableau, and data scientists and data engineers and data mining and data monitoring people utilize the data. And in between also, there we have a one process called data mart. Did you heard about anywhere? Data marts? Data marts. Data marts is for segregating your data, like sales data into one mart, HR data into one mart, point into one mart. Okay, some marketing data into one mart, so that it will use it to segregate your data. Segregation is different, transformation is different. Transformation means, let's say for example, if any columns was not matching, so that we can change your columns. If any conversions are there, like dollar to rupees to dollars conversions, or some aggregations will be there, pivoting operations, that all will be as a transformations. But categorization is different. Okay, specific Snowflake people into Snowflake, DevOps people into DevOps, like that. Segregation will be good. Clear? That is implemented in between the data warehouse and other data like BI tools or data scientists or data engineers. Actually, everybody needs a data warehouse. It acts as a centralized system. You can see. Clear? What is Snowflake? Snowflake is a cloud data warehouse on AWS, Azure, and GCP. Okay, so we need a resources. All these resources was maintained on company premises only. That refers to on-prem. All these resources was maintained on some other place. Via internet, you are accessing that resources. That refers to cloud. So in our data warehouse, what resources you need? RAM, CPU, and storage. RAM and CPU call it as a computing power, whereas storage will be called as a permanent storage. Clear? Now the cloud refers to the servers that are accessed over the internet and the software and database that run on those servers. A data warehouse is defined as a centralized repository of data stored from the range of sources within the beyond of enterprise. So actually right now I showed no? All this in detail I showed. Drawbacks of on-premises data warehouse is use capital required to purchase physical hardware, limited scaling, huge infrastructure required, take times to install and configure, waste of resources during IDL, latency issues for other location, maintenance overhead, no disaster recovery. Why Snowflake, Amazon Redshift, BigQuery, Teradata, Azure Synapse, Analytics? Why Snowflake means? First most important point is hybrid architecture. It will be supports for shared disk and shared nothing elements. So where we have a Redshift, shared nothing only. BigQuery, shared nothing. Teradata, shared nothing. Whereas Synapse is Azure, shared disk. More serverless, more self-management, serverless, more self-management, more serverless. Cloud based, all are cloud based, high, good, high. Scalability, horizontal and vertical scaling will be supports. Horizontal means
Giant operations.
no. Like say for example, you have a cluster 1, cluster 2, cluster 3, 10 clusters are there. Okay. So you are adding a one more cluster and decreasing the one more cluster. Okay. That is called horizontal scale. Scale up and scale out and scale in. Scale out. Scale out means increasing the cluster.
Within the cluster, we are increasing the servers.
No. Outside the cluster. Outside. Cluster is adding and cluster is decreasing. Okay.
Okay.
Cluster means combination of nodes. Okay. Let's say one cluster will be added with another two clusters, and three clusters will be decreased with one more cluster. So cluster out, sorry, scale out, scale in, call it as a horizontal.
Okay.
Within the cluster, you have 100 servers. You are increasing 100 servers to within the cluster.
Okay.
You are decreasing the clusters 100 servers.
Mm.
That means scale up and scale down.
Okay.
Scale up and scale down. That is called vertical scale. Vertical scale. Within the cluster, you are decreasing the nodes and increasing the nodes. Scale up and scale down. Call it as a vertical scaling. Within the warehouse, you are increasing the clusters and decreasing the clusters. Like scale out and scale in. Call it as a horizontal. Both will support. All will support. And security is high secure. And also in Snowflake, time travel feature, file safe. Okay. And coming to that zero copy cloning, data sharing is easy.
Mm.
Okay. Streams and tasks. Streams and tasks will be available anywhere, but that's for good manner. Okay. Already discussed in the Snowflake architecture, come micro partitions. Most important why we are going with Snowflake means first point is hybrid architecture and the second point is hybrid columnar storage. It will store the data in micro partitions so that you can easily search your data, fast search. It is a combination of row and columnar partition. You want more detail, please go through the previous class. Still you are not understand, you just ask me in next class. Time travel, zero copy cloning, data sharing, streams, task, and file set. See, this is most modern data architecture. Right now I showed.
Yes.
Let's say, for example, if you choose a Snowflake, for storage and computing, you can choose any of your compute cloud. Any of your cloud.
Mm.
Okay. At the time of installation, you need to choose your cloud provider so that the cloud providers will provide you storage and computing. Okay. So, and after that, do your data consumer operations. Almost all ecosystems it will support, sir. It will integrate to BI tools, it will integrate with ETL tools, it will integrate with the machine learning algorithm tools, and it will integrate with the AI tools. Almost all ecosystem will support for Snowflake. Clear? Next, what is architecture of Snowflake? So architectures of Snowflake includes 3 layers. Okay, so for that I will open one image. 3 layers Snowflake architecture. Snowflake architecture consists of 3 layers. One is data storage layer, another one is job query processing layer, and other one is cloud service layer. Okay, data storage layer. Let's say, for example, you choose your Snowflake account with AWS. Okay, now AWS is providing a computing and storage for Snowflake. Okay, so data storage layer means, let's say your storage like hybrid columnar storage micro partitions. I tell na, that micro partition storage will be maintained on this AWS in S3.
S3 bucket.
S3 bucket.
Mm.
Clear?
Yes.
That is called data storage layer. And after that, job query layer. Let's say, for example, same AWS is providing computing power na?
Yes.
Computer in computer in AWS EC2. That means EC2 is a one server, one node. Okay, that nodes will be combined as a one cluster, and the cluster will be defined on the virtual warehouse. That means how many computers you want, how many clusters you want, that will be defined on the Snowflake only.
Yes.
In the form of virtual warehouse. But the nodes will be allocated by cloud. Any cloud like AWS, you are choosing, AWS will provide in the form of EC2. Got my point? Let's say one cluster consists of 10 nodes. The 10 nodes means 10 servers. 10 servers means EC2 instance. That EC2 instance was provided by computer machine, called as any cloud called AWS. That is called job query processing layer. That means this is used to compute your data, to process your data, to query your data. So that's why this will be available on query processing layer. Next, coming to the cloud service layer. So cloud service layer means it's a Snowflake layer. We just call it as a Snowflake layer. So authentications, access controller, automatic optimizers, infrastructure managers, security, metadata, everything will be on cloud service layer. Everything will be same. This metadata will point into this storage. This virtual warehouse will point into this computing. So that these three layers will combine to your operations. Let's see here. Cloud service layer, query processing layer, storage layer. Cloud service layer is a brain of system. So it has a brain. It will use it to identify the things. And also query processing layer is a muscle of system. Like it will process your data in the form of virtual warehouses. Virtual warehouse in the Snowflake is computer missions in the form of clusters. In the form of clusters. Storage is a hybrid columnar storage. You can maintain your data into a hybrid columnar storage. Call it as a combination of row and columnar storage. Cloud service layer, brain of the system, managing infrastructure, access controller, security, auto optimizers, metadata, and other things. Whereas a query processing layer, muscle of the system, performing MPP, massive parallel processing, means at a time multiple processes are involved in the process. Okay, so that to speed up your operations, it will be helpful. Coming to the storage layer, hybrid columnar storage, call it as a blobs. Now we already discussed on last class what is warehouse. Warehouse is a cluster of computer resources in Snowflake. Warehouse is a cluster of computer resources in Snowflake. A warehouse provides the required resources such as CPU and memory and a temporary storage to perform various operations in Snowflake. Warehouse requires for select statement DML operations. What is DML operations? Like delete, update, insert.
Update, delete, merge, that all.
But all these are DML operations. For this DML operation and select statement, definitely warehouse is required. For DDL operations, no need of warehouse. Sir, for create, no warehouse, no computer is also, no need, sir. For describe, no need, sir. For use command, no need, sir. Okay. For show command, no need of computer. Okay. For DDL operations, example is use, describe, show. Okay, these all are DDL operations. For that, no warehouse is required. Now, warehouse available in different sizes, like T-shirt sizes, like small, medium, large, X large, double X large, triple X large, like 5X large. Let's say, for example, if you choose a medium size warehouse, then your warehouse will be allocated with a medium size. Okay, and the cluster includes 8 nodes. The cluster includes 8 computer nodes. Let's say if it is large means 16 nodes. If it is double XL means increased nodes in the cluster.
32.
If it is 5XL means 512 nodes. That means one cluster includes the nodes. That means small to medium, medium to small. That is called vertical scaling. And the cluster support in the Snowflake is 1 to 10. 1 to 10 clusters it will support. Let's say if you choose two clusters will be added. Within the two clusters, if it is a medium means 8 nodes, 8 nodes. You got my point?
Yes.
For example, your warehouse will be a 5x large. 5x large. You have a 3 clusters. Then one cluster consists of 512 nodes. 512 nodes, 512 nodes, like 3 times. How it will be processed? Too much fast. And cost will be also based on your size and based on your clusters. Clear? But you need to define in the form of size as well as clusters. How much clusters you want from 1 to 10. You can choose between 1 to 10 and you can choose your size between XS to 5XL. XS to 5XL. XS means 1. 5XL means 5 12 nodes in the cluster. Clear? I will show you. So a Snowflake credits in the unit of measure and it is consumed only when the cluster is using resources. I already discussed this thing. So when you using the resources, then only the cluster will be consumed your credits. That means money.
Mm.
In the form of credits, it will be consumed. What is credits? I will tell later.
Yeah, yeah.
So DDL means alter, comment, create, describe, drop, show, use. Whereas DML means insert, update, insert into multiple tables, delete, truncate. Whereas DQL means select. For this we need a warehouse. For this no need of warehouse. 6. X small. XS.
Small.
1 cluster. Cluster consists of 1 server. Small 2. Medium 4. Large 8. X large 16 nodes. 2x large 32. 3x large 64. 6x large 5 to 1.
Sir, what is the node size?
So node size is not defined, sir. We don't know actually. No block was written by that one. So Snowflake is not revealing that node size actually. So I tried to read it, but I didn't get exact node size. So if you
Okay.
get, please intimate to me. It is not
Yes.
revealed by Snowflake. Clear? So XS means 1, S means 2 nodes, like 6x large means 5 to 1. Okay. Multi-clusters also supports. Like at a time you can involve multiple clusters like this. This is S cluster. S means 2 only, no? 1 cluster, 2 cluster, 3 cluster.
What about RAM?
RAM also same. Both all computer combinedly call it as one RAM.
GBs. In GBs they will not
Yes,
mention.
yes, definitely.
They will mention about the in GBs, huh?
In
I mean,
GB
16
only.
GB, 22, 32 GBs like that.
That's what that computer, how much hardware requirements we don't know.
Okay.
This node, whatever this node, this is a computer. Don't see as an image. This is computer, na?
Yes.
How much size it is there? We don't know. We don't know. We just ask Snowflake. I need a small size.
Okay.
I need a medium size.
Hmm.
Like that. Small size for medium size, the computer hardware requirements also change, and the nodes also increase. Clear? But there is no block to read about it. Didn't get, maybe I didn't search exact keyword, maybe I don't know,
Hmm.
but I didn't get that information in any of the Google.
Okay.
Okay, if you read about it, please intimate me how much size it will be.
Okay.
Maybe some keyword issue also may be there. For you, maybe it will get some information.
Okay.
You just check it. But I don't have much knowledge about the node size and everything as of now. Okay. So automatically scaling, sir. Scale up, scale down.
Yeah.
Scale out, scale in. Automatically it will happen based on your configuration.
Okay.
Auto scaling. Okay. There we have a two policies are there by creating a virtual warehouse. Need standard and economic. Standard means it's a favor starting additional warehouse. Okay. Standard means it's try to add a one more cluster to your warehouse. Within the warehouse, you will add a 1 to 10 clusters. Na? So based on your configuration, if loads are coming, immediately based on the standard, it will add a one more cluster. It won't waste the time. Immediately it will add a cluster. But economic means it's a budget friendly. It try to engage within the cluster.
Okay.
Load is engaged within the cluster. It don't add a cluster immediately.
Yes.
After 5 to 6 consequent checks only it will be added.
Okay.
Say that's what. Standard means prevent minimal querying by favor adding additional clusters over consequent credits. Immediately when either a query is queried or system detects that are more queries than can expected by currently available clusters, immediately it will add a cluster start. One more cluster added. Cluster went down after 2 to 3 consequent checks, immediately it will down. Got my point?
Yes.
But where we have an economy, only the system estimated there enough query load to keep the cluster busy for at least 6 minutes. After 6 minutes, it won't support, then it will try to add a cluster. When it will be down, 5 to 6 consequent checks. This is budget friendly. This is normal. By default, it will be follows. Okay, it is recommended. Clear?
Yes.
Now Snowflake editions. Snowflake editions standard introduced to level, whereas enterprise additional features for the needs of large scale enterprise. Whereas business critical, even highly level of data protection for organization with extremely sensitive data. So both are similar almost, but companies choosing this business critical, you can choose it also. 30 days free trial you will get. Virtual private, I already told you, dedicated virtual Snowflake cloud
Yes.
is in the form of virtual private. Standard, complete data warehouse, automatic data encryption, time travel up to 1 day only. Disaster recovery for 7 days beyond the time travel. Secure data sharing, primary support 24/7. Whereas enterprise, all standard features, multi-cluster warehouse, time travel up to 90 days, metallized reviews,
Search optimization.
search optimization, column level security also available. Whereas business critical, all enterprise features, additional security features such as data encryption everywhere, and extended support, database failure, and disaster recovery. Virtual private means all business critical features, dedicated virtual servers, and computer completely separate Snowflake environment. Clear?
Yes.
Snowflake pricing. Snowflake pricing will be for only computer and storage.
Yes.
Mostly, and other features also there we have some charges, but it will be negligible, and that will be also way off by Snowflake. Why? Because every Snowflake account, okay, now 10% of credits will be way off. So with the 10%, others will be covered. That means the major thing is for computer and storage only you need to pay.
Okay.
Got my point?
Yes.
Anywhere the computer and storage needs to be paid or not. Anywhere, any technology or any, even if you purchase one laptop also you need to purchase computing and storage or not.
Yes.
That means it's not considered. That means still Snowflake why it is surviving means even though if you compare to other and competitors, it is cheaper only. It is not considerable. The cost is will be not considerable. Even for example, AWS having a Redshift. Redshift is in Redshift. For Redshift, we need a computing and storage. Na? Who will provide it? AWS.
Yes.
For them also, for clients, they will charge or not?
Yes.
Computing and storage. Definitely they will charge it. Same like this Snowflake also they are charging. Same like that for Snowflake also they are charging. For Snowflake they are getting discounts, and Snowflake is collecting the money from users.
Yes.
As for 1 rupee, 2 rupees, they will
Yeah.
keep as a profit and doing the business.
Yes.
It's none of our business actually. We'll just talk about Snowflake. We don't want to talk about AWS. We don't talk about Azure. We don't talk about Google. Why? Because Snowflake will talk with them. We just create your environment in Snowflake, and you need to pay the money to Snowflake. Snowflake deal with that. Clear? Yes. Charge for active warehouse per hour. Please mute yourself. Please mute yourself, sir. Sorry, AVD group. I forgot to record this session. No problem. I will share the video into your drives. Don't worry about it. Okay. Others, Aruna, Bhushan. You got my point or not? Arshal, Deepali. If I forget it, I forget it. Don't worry about it. I have some backup. I will record the same section in GoToMeeting. Okay. Don't worry about it. I will share that video into your drives. Okay. So I didn't see that. At least you just talk with me so that I can understand. I didn't see that message actually. 8:24. Even 8:24 means it's not after 40 minutes it will be recorded. No problem. I will share it. Don't worry about it. Depends upon the charged for active warehouse per hour. Okay. So and depending upon the size of warehouse, billed by second. Minimum of 1 minute. What is minimum of 1 minute? Let's say, for example, this is our warehouse. For example, WH1. Okay. You are running this WH1 for acquiring your data, for processing your data. Okay. Now it is 15 seconds. Will be charged for 1 minute. Stop after 15 seconds also. It will charge for 1 minute. Now you are in 61 seconds. It will charge only for 61 seconds. If you are in 68th second, it will charge for 68 seconds. First to 1 minute, if you use 15 seconds or 40 seconds or 59 seconds also, it will charge for entire 60 seconds. Even 1 second also utilize, it will charge for 60 seconds. First to 1 minute will be considered. From 1 minute onwards, it will charge by second. Got my point?
Yes.
Let's say if you use 60 seconds, nothing will discuss there.
Yes.
Okay, for 60 seconds only it will be charged. If you use 1 second also, it will charge 60 seconds. If you use 10 seconds also, it will charge 60 seconds. From 60th second, it will charge by second. Got me? This is one of the very important internal question as well as certification question.
Yes.
Certification question. Build by second, minimum of 1 minute. Charged in Snowflake credits. Monthly storage fee. Computer is per hour. It is monthly storage fees based on the average storage used per month. Cost calculated after compression. Cloud providers based on the cloud providers. Let's say, for example, AWS cost is different than Azure. Azure cost is different than GCP.
Yes.
Clear? Next. Coming to the Snowflake prices, I already told you it is consumed in the credits. You need to purchase your credits in the form of any money, dollar. Okay. So the prices will be like this. For example, if you choose a business critical, most of the people are business critical, but we are using enterprise. Anything, both are same. Okay. So enterprise means 5.4 credits. Per credit, $5.4. You want 100 credits means you need to give around 500 or $520. $520 for 100 credits. So in this case, if you choose some warehouse like this, for this 0.003 credits per second.
Yes.
Like per second 0.003 and means per hour. Calculator. Hour, how many seconds? How many seconds per hour?
0.18.
Not 0.003
3,600.
into
2600.
2,600.
1.8.
$1, one credit. One credit.
Yes.
So if you use X small for 1 hour, you need to pay 1 credit. 1 credit means how much dollars?
1 credit means $1.
No.
$1 80 rupees.
$1 rate rupee. How much? 5.4.
5.4.
$5.4.
For business critical.
Dollars.
Okay.
So 5 into 80. Almost 400 rupees you need to pay for if you use X small per hour.
Yes.
400 rupees. Same like that if you use some large means it will be around 1600. Clear?
Yes.
This is for this AWS region. So if you choose Azure or GCP or AWS within this Virginia or Mumbai, the again cost will be different.
Yes.
I will show you at the time of a dedicated class will be there. Pricing class I will show you. Next is Snowflake roles. So we have These roles are there. Most highest privileges is account admin. Our overall classes will be done with account admin only. Okay. So after that, I will show you some differentiation between these roles also. Account admin, security admin, user admin, public, and sysadmin. Highest privilege is account admin. Account admin is a combination of sysadmin and security admin. Top level role in the system. Top level role in the system should be granted only limited number of users. Whereas security admin, user admin role is granted to the security admin, can manage users and roles, can manage any object granted global. Okay. Sysadmin, create warehouses and databases and many more objects. Recommended that all custom roles are assigned. User admin, dedicated to user and role management only, can create users and roles only. Whereas public admin, automatically granted to every user, can create own object like every other role. Okay. Available to every other user and role. Clear? Just go to the installation. So please share the notes PPT and then sure, I will share it. I will show it. I will share all this PPT to your groups. Don't worry about it. Now, first point, sir. What is Snowflake? You know. Why Snowflake? You know. Where Snowflake means anywhere. Anywhere. It acts as a centralized system. Anywhere it will be useful. When means in 2013. Okay. When means in 2013. Got my point? Now, warehouse means two things you needed. One is computer and storage. Computer and storage will be provided by any cloud vendors based on your choice. Okay. If you choose any cloud vendor, they will provide a computing and storage. Storage is in the form of hybrid columnar storage. Okay. That will be pointing with the help of metadata in Snowflake. In Snowflake, metadata will be there. The metadata will pointing to your actual columnar storage, hybrid columnar storage in the storages, S3 storages, called as a AWS cloud or Azure cloud or GCP cloud. Clear? Now, computer also getting from any cloud vendors, and that will be decided in the form of virtual warehouse. In the form of virtual warehouse. In the virtual warehouse, you need to define what is the size of virtual warehouse and what is the cluster range from 1 to 10. Based on that, you will get a computing power from the cloud vendors. Clear, sir? Now, if you want to see your Snowflake account, just start installing your Snowflake account. So go to the Snowflake account. Just go to the any browser. Just click on snowflake.com. Snowflake.com and click on free trial. Click on start for free. Now pass your first name, any name, for example Ravi. Classes is my second name, and email, company email is asking, but don't worry, your personal email also you can provide. Ravi classes 35@gmail.com is my email. And company name, let's say for example any company name you can give, for example IBM I am giving. And role, whatever the role you want, you can give. BA analyst, business executive, whatever the consultant, data engineering, data, any role you can give. And India, and click on continue. And it will ask for the what is the Snowflake edition. So I'm going with enterprise or business critical. Anything you can go. So I'm going with enterprise. Okay. So I will show you business critical on next installation. Okay. So enterprise and choose your cloud provider. Okay, any cloud provider. Which cloud provider you want for computing and storage?
Microsoft Azure.
You want Azure?
Azure.
Click on Azure. Azure. So which location you want computing and storage?
Central India.
So Pune is okay. India, Pune is okay for you. Okay, that means Azure, Microsoft people is providing computing and storage for Snowflake on Pune.
Yes.
Again, I am repeating, for this account, Microsoft Azure will provide computing and storage on Pune. Clear?
Yes.
Now check it and click on get started and skip. Now it will send one email to your email address. Open your email address. Now see, click on, still refresh.
Can you check in a spam?
Ravi classes that of Snowflake. So click on activate to your Snowflake account. Click to activate. Okay. So actually this is your instance actually. Okay. Just click to activate first. Okay. Click to activate and it will open ask for username. You need to provide your username. Okay. Let's say for example, I am giving Ravi classes 35 is my username. Okay. And the password and password confirmation. Okay. Control minus it will comes like this. Okay, if you don't run it, it won't visible. Okay, just control minimize your screen and then get started. Now it was create our account. Okay, now you just take this link and for feature purpose I'm just making this as a notes. So after 30 days, this will be expired. You can create your own account. Clear?
Yes.
Again, new account with a new mail. Azure provider. Okay, just save it. Now copy this one link. Every time you want to log into your Snowflake account, just open and copy it and open a new tab and run it. It will ask for the username. Whatever the username you provided previously, you just mention that the username that is 35 and password and sign in. And it will open a page like this. Okay. Now we can check here Ravi classes name. You just go to the switch role. Here you can switch your roles. I am using account admin as a default. Why? Because he is the highest privilege. Everything I done with the account admin only. Now click on profile and it will open a profile. You can upload your photo and also you can change your first name, last name, and you can change your password here itself, and you can change your email address also. Okay, so if you want notifications for your something like resource monitoring and any background queries, just click on it and then for understanding purpose 35 just save it. Clear?
Yes.
Now click on dashboards. You can create some basic dashboards also, like some basic like Tableau, Power BI. We can create multiple visualization. Whatever the statistics we can create as a table or bar chart or some column chart. Okay, so I will show you on later about this. Next, coming to the data. Here you have a database. You can create database here. Some sample databases also available here. Okay, now click on database. Now create a database. What is the database name? Database 1. And this is my comment. This is my first data. Sorry, is 1. Now create. Database was created.
Yes.
Database object was
Create.
created. Under database object, you need to create a schema. What is schema?
Collection of tables and data model.
A user in
Logic,
database.
logical structure of objects. So, what are the popular schemas available in our market? Star schema and Snowflake. What is star schema and what is Snowflake schema? For understanding purpose.
One fact table remaining all are dimension tables.
One master table with one dimension.
Let's say, for example, this is fact table and this is all dimensional tables. So central fact table and remaining all are dimensional table. It looks like star only, no?
Yes.
That's why it's star schema.
If you create sub-dimensional tables for this,
Let's say
they
it's
will
a
become
fact
a
table.
Snowflake
That
table.
is Snowflake.
So these all
Dimension
are,
table is connecting with the unknown dimension table.
yes, D, 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 and D, and it will be connected with a sub-dimensional tables. This looks like a Snowflake schema. Got my point? This is Snowflake. So what is fact and what is dimensional?
What is the
The table which has a primary key is called fact table.
No, primary key is
Means
in dimension table. Foreign key is located in fact table. Like a fact table have text numerical data. Dimension table have textual data. Like sales data stored in fact table.
yes. Let's say, for example, for easy understanding, some people are from non-IT guys, na? For easy understanding, let's say, for example, you have a one store, okay? Some Ravi user, so what's your name?
Rajesh.
Rajesh, some X user and Y user is purchase some products like banana, apples, pomegranate, okay, brinjals and carrots. A lot of vegetables they purchase. Let's say, for example, 10 vegetables.
Yes.
For 10 products, what is the price? What is the sale price? What is the quantity purchased? And what who purchased Ravi? And what is his phone number? And what is your address? Okay, everything you need to go now.
Yes.
Every 10 records, same like Rajesh purchased some 20 products. For 20 products, what is the product name? What is the change quantity? What is the quantity? And what is the price? What is the sale price? And what is the customer name? What is the mobile number? What is the customer address? Like X person, Y person. This all the data is maintained on one place means what will happen? Data
Performance very
redundancy.
slow.
Data redundancy will be happening. Performance will be happening. So for that, what they will do, whatever the common values, like for example, for me, 10 values is repeating.
Yes.
For you, 20 values is repeating. For X value, 15 values is repeating. For Y value, some 30 values is repeating. Okay, that means name, customer name, and this that phone number,
Will
email
normalize the tables.
address. Four columns are repeating. So for that, I will create a employee table. In that, I will give you one ID for a Ravi. Okay.
Okay.
And then everything added here. For Rajesh, I will give one more ID. For X person, I will give ID. Y person, I will give ID. Instead of adding multiple record, we'll just pass a employee ID that 1, 2, 3, 4. That time, out of all 10, 20, 15, 30 records, only you can give one employee ID is enough. This is called actually fact table, and this we call it as a dimensional table. Like that, multiple dimensional tables you can create, which point into your fact table.
Yes.
So that will be combined with a foreign key and primary key. Okay. In Snowflake, no need of this all headache process. Don't worry about it. In olden technologies, what will happen? You need to design what is the schema first, and after that, you need to combine with primary keys and foreign keys and other things. Okay, you need to create first a logical structure. In Snowflake, no need. Just simply it will create a schema. Let's say for example schema 1. This is my first schema. So I will give you access later. Just create it. See, schema was created. Which schema it was created? Snowflake schema. And also here to combine the multiple tables, no foreign key and no
No.
primary keys are there. Snowflake automatically attach the data in the form of micro partitions, in the form of cluster keys.
Okay.
No need to done by any user. Snowflake will take care about it. In the form of cluster keys, it will combine multiple tables. Okay, it will identify the cluster key and it will show the data into micro partitions. While such operation is going on, it will search the specific micro partition in the form of so and so cluster key. No need of primary keys and so cluster keys. Got my point? Simple thing. Once you create a schema, in the schema, you need to place different objects like tables. Tables are different types. What are the tables we will see later. And views. Views are standard materialized views, secure and secure materialized views. Stages. What is the stages? All stages will be supports for all present cloud vendors like AWS, Azure, GCP. Storage integrations and also file formats it will support. And sequences, incremental sequences are there. And also almost all file formats that will support for Adobe like Parquet2, CSV, JSON, XML, ORC, Avero, all will support. Pipes also created. Pipe is exactly used for continuous data. Like if you want to get the continuous data into Snowflake, that time you will use a pipes. Streams mean changing data, only changing data. Task means scheduler. Functions also you can use, UDF functions like that. And also procedures, store procedures also you can create, and dynamic tables also you can create. These all are the objects. How to create all these things, we will see on next class. Okay, next coming to that, after creating this all objects, you can share these objects to the different accounts like Snowflake accounts with as a non-Snowflake accounts also. And coming to the marketplace, you'll get some data in the marketplace for the practice purpose. You want to download some free data for sampling, you can download it. And also you can place your data into marketplace also, like a Tableau publisher like that. Okay. Activities, whatever the activities you are doing on the Snowflake, everything will be registered here. Right now I created some database schema, it will be created like this. Okay, as a activities. Any copy history, copy means loading the data. Loading the data will be done with a copy command. So any loading of data history will be checked with a copy history. Okay, no loads happen, that's why no copies are. Task, what are the tasks you have, the tasks are running or not, that will be checked on task history. Dynamic tables will be checked here. Okay. And also admin task. So if you can create a usage, you can check the usage of your account, what is the usage of your account. And if you want to create a warehouse, you can create a warehouse. Warehouse means compute power. So by default you are getting a compute warehouse. One is the default warehouse, that's the size of access. Okay, cluster of 1. Okay. And if you want, you can create your warehouses. Next class we will see how to create your warehouse. Now resource monitoring. What is the computer resources? What is the warehouse one resource usage? What is the warehouse two usage? What is the account level usage? You can create some alerting system on resource monitoring.
Okay.
Like for example, your credits are consuming more than 100, you'll get one alert on resource monitoring.
Yes.
That will be in resource monitoring. Users roles, you can create a users here and roles here. Customizer roles. Security will be here. Billings will be secured here, and also you can check contact information about your account, and also account information. What is your account? This is your account, and cloud is Azure, and region is Central Pune. Created 50 minutes ago. Creator, this is the locator. And partner connectors, it will connect to almost all ecosystems now. Let's say for example you want to integrate with the informatica, you want to integrate with the Matillion. It is one of the ETL. You want to integrate with some ADF is not support, integrate with some other Python operations. Let's say for example talent, Alteryx also one of the ETL.
Abnisio.
Yes. So ETL process.
Abnisio. ITL tool I'm saying about.
ITL is.
ETL. Not Altis. Tool name is Abnisio. ETL tool.
Okay.
Not there.
Not there. Otherwise, you can use other methods to integrate. I will show you some Python integration and ODBC, JDBC drivers will support.
Yes.
Okay, so no problem. Next, for example, we want to check with talent. Talent is also one of the area. Okay, DBT.
Informatica.
Informatica already done. DBT. It is also a data transformation tool, not ETL, data transformation tool. Apache Airflow, this will be support with Apache integration. Okay, connect us up. Informatica already know.
Yes, sir, there is a tab
Okay.
called data integration. I think there you can find all the data integration tools.
So these all are that only I am searching actually. Anything all category I am checking previously. Data integrations means this one. Clear? Otherwise, you can use ODBC, JDBC drivers or other connectors methods. Okay, and help and support. If you want any problem you are facing on this account, you just enable the support and ask your questions. So this is what actually account. You just take the account and I will show you what is worksheets and how to create your worksheets with the help of SnowSQL. Okay. So on tomorrow. Any questions, please ask me.
Snow Insight and Classic WA.
Basically, right now we are using a Snow site. 2 months back, you have a chance to go with a classic console. Okay. Now it is not available on free trials. You need to do everything on Snow site. This is Snow site console. Snow site console. Snow site versus classic. Previously, 2 months back, you have a classic console, but right now there is no chance of going with classic console. You just go with the Snow site only. Okay, everything will be teach on Snow site only. Okay, but the upgradation is happened, only Snow site is available, but no changes happened between the process. Okay, only view UI will change. The structure of your looking will be changed. That's it. Okay, if you want to look about the classic console, I will share some video. Okay, previous 2 months back I just share the classic. I will share that video. If you want to see the classic console, you can see on that. Okay, that's all enough today.
Sir, I
So
think
any
classic
ask me.
console.
Yes, please. I'm sorry.
Sir, I think classic console is disabled by Snowflake. Classic
I'm not
console
getting
is
you.
disabled by Snowflake.
Can you please repeat again if I am not getting you? If you don't mind, can you please repeat again? Any questions? Adarsh, Aruna, Bhushan, Deepali,
No, sir.
Harshal?
Please share a note, sir.
Sure, definitely. I will share it. I will share this video also. So you can expect after 2 to 3 hours on your drive.
Okay.
So I will share this concerned person. So she will update into your drives.
Hello, sir.
Yes, please.
If we choose AWS Cloud, then any effect on our Snowflake operations?
No, I already intimated now. If it is AWS or Azure or GCP, it is none of our business. Snowflake will take care about it. Okay, only the matter is cost. Only the matter is cost. That's it. And region wise, and I already explained you what is the benefits you are going with choosing. Let's say for example your most of clients are from Azure background, so that you can convey easily a Snowflake is using your same cloud, man. No problem. Our data is in same cloud, man. Data cost and data transformation also very easy, man. Like that we can convince. Okay, but it is not, I'm not saying that Azure and AWS won't integrate. Even your data is in AWS, your Snowflake is in AWS, you can directly deal with Azure clients. You can get the data from Azure also, like GCP also. Why? Because you are not going to deal with a cloud persons, you are going to deal with Snowflake people. Okay, that's all enough today. Thank you, thanks for your join. Bye.